The sixth domain is security assessment and testing. Here, the focus is to test the controls or test the applications to check whether it meets the security requirements. And also assessment includes audit, periodic internal and external audits to verify the controls functioning. Now in this session, we just take a look at the top, the SANS Institute has categorized the top most 25 vulnerabilities into three categories. They have categorized under three categories. The topmost dangerous software errors or vulnerabilities. Let us see one by one. The first and the foremost is insecure interaction between components. In software, many components interact with each other, like components in the sense it could be a subprogram or modules or programs, processors within the operating system, or it could be thread or a system. These are all components of a software where they interact by exchanging information like data. The one processor sends data to the other and other returns the computed result. So this interaction is always a risky area where security can be broken. Here, how to be safer? One should not employ insecure ways during the interaction of modules. There are standard secure ways of communication that should be practiced. And the second one is risky resource management. The way in which software does not properly manage the creation, usage and transfer or destruction of important system resources. The handling of the system resources is very risky. So here again, the best practices are to be followed in order to avoid any risk that could happen. And lastly, a very straightforward category. This is porous defenses. That is a very leaky defense. The defense techniques are often not properly used, misused or abused or ignored. For example, the policies might be written and the guidelines are also very clear, but in practice the users, they often misuse or abuse, or sometimes they ignore. This is again an important category of software errors. In this session, let us look at the strategies for assessment and testing. Because the policy, procedure, guidelines are based on the strategy should be very strong and long term. Here the questions are asked: are the systems effective, suitable and survivable? And based on this, the testing strategies should be planned. And what about the system performance? How do I check it? Whether it is up to the expectations. And what about the risks? Inform risk and mitigation. What is that? How do you evaluate the risk, and what is the mitigation for those risks? Support acquisition as well as development of programs, both internal in-house development, also acquire from outside off the shelf. How you are going to evaluate, and finally test and evaluation process whether it is consistent with the acquisition strategy. See, after you acquire the software, how do you evaluate? How do you test it? Whether the process is going to be consistent, test and evaluation processes. These are all the questions. Based on that, the strategy is formed. Now coming to the software development, the verification is an important process. Verification is nothing but an evidence that the output of each phase of software development lifecycle meet all the specified requirements. At the end of the each cycle, development life cycle, one should ensure and look for evidences that outputs of each phase meets the specified requirements. Otherwise, we are not meeting the objective, the requirements. Look for consistency, completeness, and correctness. How? Using software testing, and then various static and dynamic analysis. Similar to testing, but it's a different analysis. Code and document inspection. Different methods of verification, these are all. Code and document inspection, in the sense the auditor or whomever is reviewing, they have to review the code and then do an inspection for any vulnerabilities and whether it meets the requirement, whether it is consistent, and whether it is complete and correct. The testing and walkthroughs, the different methods of testing. Walkthrough is going through the design documents, going through the code, going through the test cases, and then checking the test results, and then the metrics. Now, the level of confidence that the software or system meets all the documented requirements and the user expectation, that needs to be validated. Users define requirements, but how do you know that the requirements is met? Users, though they define requirement and intended use of the finished system, users they have already provided that detail, but don't necessarily determine whether the requirements will be met by the software or hardware. The requirement is there in the hand, but the acquired system or the software, whether it meets the defined requirement. That is what the validation, the validation part. And the design validation includes confirmation that the system conforms to user needs and intended use. Software validation includes conformance to and the traceability to system specifications. Right from the requirement stage, next to the design, development and testing, traceability should be maintained. With respect to this particular requirement, this part is the design, and for this design this is the code, and for this code this is the test case, and for this test case this is the test result. It should be traceable right from the requirement up to the end. So that is how the validation can be performed. Some of the other strategies include log reviews. Log reviews helps to identify security incidents, policy violations, fraudulent activity, operational problems. Very useful. The log gives plenty of such information when it is correctly looked at. And the logs may also help with performing audits. The auditors will require logs, and in case of forensic analysis, for any incident analysis, forensic analysis logs are used. For internal investigations and establishing baselines, identifying operational trends, identifying long-term problems, everything is coming from the log. The use of log is very important. However, the log cannot be readily read. It cannot be readily read because some of the logs format will be different. Some will be in binary, some may be in text. And how do I correlate all? So there are a lot of tools available, log analysis tools, that can be deployed to study the log information and bring out the meaningful result from the log files. In this session, we are going to be taking a look at log management. Logs are created by various systems, applications in different formats and with varied details. So let's look at what SANS Institute says. SANS Institute Critical Security Control says that maintenance, monitoring, and analysis of audit logs, which is basically the log management. Management is to maintain the logs, to monitor the logs, and analyze, and then get meaningful information out of the log. Why log management ensures computer security records are stored in sufficient detail for an appropriate period. Certain logs are to be stored for longer, and certain can be deleted, can be erased within a short period, depending on the requirement. However, in general, if an incident happens, first thing to look at is the logs. So it could be if the incident has happened today, but you may come to know later on. It is not that one would immediately identify. Some incidents gets identified if it is very high critical. Some incidents go unnoticed, and sometimes later one would find. So that time, immediate requirement is to refer the log on that day what has happened. Common security related OS data are system events and audit records. System has several events like startup, shutdown, crash, or any such thing. All gets recorded. What is how do I perform the log management? To start with, it has to be the requirements has to be defined like in any other case. First is the requirement. The second comes the policy. Identify the requirement, define the logging requirement for the organization, then create policies based on that requirement, which includes what logs are to be generated, which are all to be transported or transmissioned, storage. What is the storage requirement? When it comes to log, the storage requirement is going to be very high. So if one enables all the logs, in terabytes it is going to be consuming. So that is where a careful requirement needs to be identified in the initial stage itself. Otherwise, it is going to be becoming a big problem in the sense the storage cannot be sufficient. So the logs require very huge amount of storage. And analysis again, it is not an easy task because various file formats, various informations are captured, and a single person cannot go through each and every log file and then identify. So there are several tools available to analyze log, and finally the disposal of the logs. Yeah, based on the requirement, it has to be prioritized. The log requirement goals based on the organization need to reduce the risk. Define roles and responsibilities for log management at a system level. In some organizations, the IT infra team takes care of the log management. Some larger organizations, there is a separate team. We have gone through SIEM earlier. So in that kind of an environment, a separate team, will be consolidating all the logs in a single place, single location or a single server, and they'll be performing the analysis on daily basis, and they'll be maintaining the infrastructure. Now create and maintain a log management infrastructure. If it is a separate infrastructure, it could be. Sometimes it could be the same infrastructure where the applications run. Like what are all the hardware and software required, what are the network requirement, media to generate, transmit, store, analyze and dispose the logs. Support policies and roles. Plan for the current and future trends. Once decided, we cannot stick on to the same strategy or on the logs, because the new tools keep coming, and the analysis becomes much easier with the new tools, and the organization changes also would impact. So the future needs to be taken into account. Support staff with log management responsibility. Provide training for them. Technical guidance, documentation, tools needed are to be provided to them. Tools is again with respect to log management, storage and tools are particularly very critical and important. What are the standard log management operations? Configure log sources, various sources are there, configure proper configuration and perform a log analysis, respond to identified events, manage long-term storage. In addition to this, monitor the log status of all the sources. There will be logs created from various sources, monitoring them, and then rotation and archiving. Again, the storage is a critical factor with respect to log. So it has to be rotated and archived and then rotated because it might consume terabytes of space. Maintain the logging software, like from time to time upgrade or apply patches as when required. Also an important thing is to synchronize the host, ensure logging host clocks are synchronized. Recognize, reconfigure if needed, like when there is a policy change or a technology change. If the company is going for a different server, then the reconfiguration is needed. Ensure logs are consolidated into central repository. We saw this earlier, SIEM. Network and host based software logs. Like these are all some of the examples antivirus and anti-malware might generate. Also IDS and IPS, intrusion detection and intrusion prevention systems will be generating the logs. Remote access software, whomever is accessing, there will be a log on that. Web proxies creates the logs. And vulnerability management, again this application or software creates logs. Authentication servers, who was authenticated when, through which source, all those things are created. Routers, all the devices, it could be a network device, routers, firewalls, and then NAP and NAC servers. Every piece of the hardware or software creates logs. Now relating to the system events, what are the typical system events that gets logged is shutdown time, start of a service, failed events, and the event data usually contains like timestamp, status, like whether failure, success. If it is a failure, then error code, what was the service, user or the system account responsible for that particular log entry. All these things are available in the log file. And this is going to be an important audit record. All these logs, records are often defined in system and logged. Successful and failed authentication attempts, again, this is getting logged. File accesses goes into the log. Account changes goes into the log. These are to be reviewed frequently. If there is an account change, whether it is an authorized change or unauthorized change, that is the purpose of the log, to capture that kind of an information. Use of privileged access, which account has who has used the privileged access, what are the in a client request and what was the server response, usage, number of transactions performed, when, at what time, application startup, close down, failure, configuration change. If some change in the application has happened, that also goes into the log. There are problems with the log. As you know, the first is the quality versus quantity. It might, the application may create a number of logs, but if the quality, the needed information is not there in the log, it is not that helpful. So there, the quality is more important than the quantity. Quantity again is a problem. Then storage management has to be storage has to be managed properly. Different sources of log, inconsistent log content, format and timestamp. Each application or each device, one server may be creating log in one format, some details it may have a timestamp in one format. Some may create binary logs. So this is inconsistent. So how do we consolidate? It is going to be a problem again. And large volume of logs created. All the logs created, goes into terabytes. So how do I manage? These are all problems. Protecting the confidentiality, integrity and availability of the logs. One should not be allowed to tamper the log files. An intruder and an attacker, after they doing stealing some data, they may want to delete that log entry. So protecting against attacks is also a problem and it needs to be taken care. And ensuring analysis of the log is effective. Analysis is going to be a tough job because of the different format and different sources. So proper analysis needs to be ensured. Where the tools comes into picture. Tools comes into picture and help analyzing the log. In this session, let us take a look at continuous monitoring. That is Information Security Continuous Monitoring, which is ISCM. Why do we need continuous monitoring? Because we want to know what is happening in near real time. It may not be 100% real time. In near real time, we want to have a snapshot of what is happening to the security controls, whether it is working. What is happening to the data and the network endpoints and even cloud devices and applications. It actually gives a snapshot of the status of the risks involved with respect to these items, data, network, endpoints, etc. And this helps us to understand the risk tolerance and the risk and to manage the risk. How well it is working, how much we are able to tolerate the risk. It gives an idea, if you are continuously monitoring. Also, it helps us to understand the metrics for the security status that include all of the organization. Metrics, gives an idea, like number of intrusions, number of failures, that kind of information you will be able to get it in near real time if you keep on monitoring. Otherwise, if you don't do monitoring, and if you are going to be reviewing after a long period, then it is of no use. A lot of things might have happened. Your risk might have really occurred, and it goes unnoticed otherwise. Continued effectiveness of the controls. How the controls are working, you can see live. Verify compliance with the information security requirements. How we are doing with respect to compliance. All these things, we will be able to understand if we keep monitoring. Maintain the visibility of the security assets. Whether any security assets got accessed by an intruder. All these things will be visible in real time. Control changes to the systems and environments. How we can, who has done, when they have done it. It helps us to understand. And awareness of threats and vulnerabilities. What kind of threat and vulnerabilities are there for the organization. So establishing ISCM strategy. First, define the continuous monitoring strategy. For simplicity, I'll say continuous monitoring instead of ISCM. Establish a program, metrics and monitoring frequency. What metrics are to be collected and what should be the monitoring frequency. It is not real time. All the uh, things cannot be monitored in real time. That is why we say it is near real time, because some of the critical assets can be monitored more frequently and some of them less frequently. And then establish the program, implement the program. By implementing, we collect information, possibly automate the collection. The collection is getting to be automated, and then do the analysis part and respond to the findings, and finally review and update. What are the typical metrics that can be collected in the continuous monitoring are, what are the vulnerabilities revealed and remediated, how many vulnerabilities were identified, and then how many remediate, whether we could remediate all or still some are pending. Unauthorized access attempts, how many per day unauthorized access attempts happening, how many configuration changes per day or per month, and contingency plan and testing, how many times we have performed. The metrics gives an idea of how the controls are working. Risk tolerance thresholds, and what is the risk score. We take decisions based on the metrics. And then the next part is establish monitoring frequency. As we were earlier discussing, each item cannot be monitored at the same regular intervals. Some need very closer monitoring depending on the volatility. So volatile controls should be assessed more frequently, monitored more frequently. Some system impacts also to be more frequently. It depends on the organization, what they would like to really closely monitor, and what the frequency can be less. That an organization can decide depending upon their business. The critical controls for critical functions may be monitored more frequently. Controls with weaknesses maybe need more frequent. So the frequency needs to be decided on these things. Risk tolerance, and then threat and vulnerability information. When how often you have to check. Similarly, the risk assessment results, reporting requirements. Reviewing and modifying the strategy. If data collected is no longer useful, then there is no point in having it stored and archived. Then discontinue to the collection and save resources. Change to the business process. So whenever change to a business process happens, so the strategy changes. Check in the change in the risk tolerance again. The organization is now able to tolerate much better, in the sense they have brought new systems to mitigate. Then the risk tolerance is high. So that time the strategy changes. So all these changes will make a change in the reviewing and modifying strategy, like change in threat and vulnerability of the organization, changes in the systems, if they are going for a different system. Then trends in reported data also, Now let us suppose the attacks per day has reduced, then the strategy has to change. Changes in the law and regulations, yes, that is also another important. Changes to the reporting requirement. Now real user monitoring, that is RUM, captures and analyzes every transaction of every user of a website. Uses local agents or JavaScript to gauge the performance and the user satisfaction. Synthetic performance monitoring is internal agents or scripts that mimic the steps of a real user. It is not a real user, it is scripts that mimic the real user, not monitoring real user sessions, because it mimics the real user. Scripts performing a known sequence of at regular intervals. Performance is predictable, and any problem earlier is easier to detect. Information gathered is more useful and more meaningful. What are the different types of this monitoring? That is, website can be monitored, databases can be monitored, TCP/IP port can be monitored. External interface, internal interface. These are all the important items that needs monitoring, real-time monitoring. This session is about the internal and the third-party audits. Audits are always independent verifications, and organizations have to go through the audits in order to comply with the regulations or to satisfy the clients. One of the common audit is a SAS, that is a Statement of Auditing Standard, SAS 70, which was AICPA, that is a American institute, accountants institute has developed this. One of the most effective ways of a service organization can communicate information about its controls is through SAS report. There are two types of service auditors report, that is SAS report type 1 and type 2. And the type 1 report describes the service organization's description of controls at specific point of time. Let us, for an example, it is on such and such a date, that is June 30th, 2010. Whereas the type 2 report not only includes the service organization's description of controls, but also includes detailed testing of service organization's control over a minimum of 6 months period. So that is the difference between type 1 and type 2 reports. Anyway, the SAS 70 was retired in 2011 and has been replaced by SOC reports, that is System Organization Control, SOC reports. Let's look at the SOC report. There are three types of SOC report. SOC1 detailed report into internal controls over financial reporting, direct replacement of SOC 70. And two other reports, SOC 2 and SOC 3. SOC 2 is a detailed one, whereas SOC 3 is a short one. The difference between SOC 2 and SOC 3 is SOC 3 is a short one which will not contain the test results, whereas the SOC 2 will contain a detailed report of the test results. What it is, SOC 2 and 3, a detailed report provide assurance for security, availability and confidentiality, processing integrity and privacy. About the organization's information systems and how they are managed and what controls are there. This is based on Web Trust and Sys Trust principles. That was developed again by American Public Accountants Institute as well as Canada. These two organizations have jointly developed Sys Trust and Web Trust principle. So it uses the trust principles and the criteria to provide assurance beyond just financial reporting. SOC 3 report commonly covers 12 months period. So what are the SOC report security principles? It verifies the IS security policy. The auditor would be doing a detailed testing, like they would review the IS security policy, security awareness of the employees, what the risk assessment the company has done. They might check the logical access control, physical access controls, whether they have implemented security monitoring and how it is working, how effective it is. User authentication, how it is performed. Incident management, is there a process, and what are the details? Whether the organization has taken care about personal security, people security, asset classification and management, whether the organization has performed this classification of assets and whether they are managing it properly. System developments and maintenance of the applications, whether the process whole life cycle, configuration management practices, change management practices, monitoring and compliance. All these things the auditors will take a detailed look before creating the reports. The same whatever we have seen, it is categorized under availability, confidentiality, privacy, and integrity. So these aspects based on these availability principles, availability policy, what is the organization's availability policy, what is the backup and restoration policies and practices. This is SOC 3 SOC principles. The auditors, SOC auditors will verify all these things with respect to any organization where they perform the audit. Like for example, whether the organization has got disaster recovery plan, whether the plan has been tested, what is the test result, if they have found out any errors in the test, whether it has been corrected and implemented, what is the business continuity management plan, whether organization has got any BCP, whether BCP has been tested, whether how it is working, how effective it is, like that with respect to availability. With respect to confidentiality, the policy, what is the organization's policy? Everything starts with the policy first. The organization, depending on its requirement, they first create the policy. So the audit also starts right from the policy. They go through the policy. Whatever the organization has decided to do, whether they are doing it as per their policy. What are the confidentiality inputs? Confidentiality of inputs and confidentiality of data processing, how confidentiality of the outputs maintained, inputs and processing maintained, in how information disclosure is done, confidentiality of information and in systems development, application development. All these things the auditor will look at with respect to confidentiality. With respect to integrity, what is the policy, whether it is complete, accurate, timeliness is there, authorization is happening properly, authorization of system processing, information tracing right from the source to the development. And similarly, the privacy principles that the auditor would look at. What is the choice of content, what is the data, how it is collected, how is used, how is retained, how it is accessed, what are the disclosure, to whom they are disclosing, whether they have an agreement, quality and monitoring effectiveness. Privacy principle, even management will be verified and notice. This talks about the audit preparation. The auditors, how do they prepare for the audit? They define the audit scope first and overall project timeline. The meeting, the first meeting with the client, the auditors, when they will define the scope of the audit, and then and they agree with the company. And overall project timeline. Identify existing or the required controls. What are the controls required? And what are the existing controls as per the company or the organization? Perform a readiness review, whether the organization is ready for the audit. Identify gaps requiring attention, communicate, prioritize the recommendations. This is only preparation for the audit. Hold working sessions to discuss alternatives and remediation plans. This preparation is done by the organization. Now the auditor is not there. This is the company is preparing. They define the audit scope. They define the company, organization defines the timelines. They only identify the existing what are the controls to be audited, and perform the readiness review. Before the audit, the company prepares these things. Verify the gaps. They themselves once rigors do the audit and then plug in all the holes and do whatever required remediation. Then the auditor comes. Now in the preparation, finally they determine the most effective audit and reporting approach for formal audit. Next comes the formal audit. The audit phase, provide a plan, collect data in advance, on-site meeting and testing, off-site analysis of collected data. That is during the meeting, the auditors might have collected the data. They go there to their office off-site and then analyze the data. Ongoing report of progress and issues identified. They keep communicating to the organizations and keep sending on an ongoing basis, keep sending reports. And draft report review with the management, produce a final formal report, provide internal report observations and recommendations. As part of the security assessment and testing domain, now we are taking a look at the code review and testing part. I have provided the whole software development life cycle here, like the first phase, the requirement phase, and then the second one is functional specification, detailed design, implementation, integration testing, system testing, acceptance testings, and finally the final verification. So throughout these all these phases, security should be kept in mind, because at the end, if the security was not considered during the requirements and functional specifications and the design time, during implementations the security cannot be implemented. It can be implemented, but it is going to cost. It will take time and a lot of effort. So always the security should be built into the design. That is an important concept. Even the quality, for that matter, quality, security, everything should be starting from the from the requirement stage. Why do we test? Actually, the requirement is the first thing. The user wants certain things to be performed. By testing, we ensure that whatever the requirement given by the user is working as expected. So that is why they basically we need to perform testing. Let us see the process, the testing process. What are the expected to test outcome predefined. When you do the testing, the result should be whatever we expect. Like it should do this, then it should do. When you do the transaction should be completed in 1 minute, then it should complete it in 1 minute. So that is predefined. Outcome is predefined. We are just checking that, ensuring that it is happening. High probability of exposing error. When you do the testing, there are chances that you will be able to bring out the errors hidden in that code. Successful test is one that finds an error. So if you keep on testing and if you are not able to find any error, it is not effective. The successful test is one that finds an error. Testing independent from coding. It should be 100% independent. Like a person who has coded, he knows how it is going to work. So if he is going to test, he will test, as he has coded. So that is why a tester and coder should be different, and that is how one can bring out the errors in the application. Both the user and programmer's skills are required for testing. The tester should know to some extent the coding, and he should have full knowledge of the user. Testers use different tools from coders. Both are different function. Like testing uses a different tool, whereas the developers use a different tool. The external examine unusual cases and usual cases. That is the correct path and the wrong path they call. We should not just test how it as expected, whether it is working, not that. There are different methods of testing, and we will see everything in depth in the subsequent slides. Documentation evidences results and allow independent confirmation. All these to be captured and documented, and for independent confirmation allows. Security should be a priority in all the phases of software development life cycle. So testing needs to be performed to detect vulnerabilities caused by bad programming. Bad programming is such a missed checks allowing SQL injection or buffer overflows. This SQL injection and buffer overflows are vulnerabilities which an attacker can exploit. This is happening because a user is not releasing. Let us suppose the coder has allocated some memory, and after usage he has to release it. If he is not releasing, then it keeps on adding. That is one coding mistake. So some such mistakes, if it is there, that it comes out. And then misconfigured security, weak access control. The coder has in his code and has performed weak encryption or weak access control. It comes out. Bugs in security, that is controls. The user might have defined a control. If the control is not implemented, then it's a problem. Bugs in security and the logical flaws allows the application to be misused. Types of testing, we take a look at types of different types of testing. The attacker normally exploits bad programming and interface problems and misconfigurations. We saw that earlier. Now let us take a look at different types of testing. What is a black box testing? Is no internal details are known are available to the tester. He is not aware of anything internal part. That is black box testing. White box testing is internal details and system is known to the tester. It is available and he can read the document and understand how it is supposed to perform, what is happening inside, and that is the white box. And dynamic testing is run and observe its behavior, actually running the code. Statics is without running the code, analyze the system without running the code. Manual testing is tested by humans, whereas automated tested is scripts or applications tools perform the testing. Attack surface, this is an important terminology. Testing, we are now take a look at what an attack surface is. The attack surface describes all the different points where an attacker can get into the system and where they can get the data out. So that is the attack surface. So when a person is performing a testing, they should consider the attack surface, application type, whether it is a client server or a Java application, any such type, quality of the results and usability, and supported technology. I was talking about client server and it's a mainframe, that kind of a technology, and performance and resource utilization. These are all the main considerations in the testing method. During the planning and design, normally it is no testing happens. It is only review can happen, like a tester can review. Now he is called a reviewer, maybe. He is not a tester, but it is broadly it is testing. Even reviewing is testing. The design reviews happens because there is no code available. Architecture security review and threat modeling is another important terminology as far as we are concerned. Analyzing how an application can defend itself against a list of pre-compiled security threats. We already have a list of threats, and analyze how the application can whether it can defend these threats. That is and then that is threat modeling, understanding the possible impacts of potential countermeasures. Architectural review is a manual review of the product architecture to ensure that it fulfills the necessary security requirements at a higher level. During the development stage, the coders are performing the coding. Application is not yet ready. So this time, so every phase, what we are saying here, earlier we have reviewed the design to find any faults, any errors are there. Now during the application development also, a static source code analysis can be performed. Or manual code review can also happen. A tester can review the code and then find possible bugs. And there are tools like analyzers, source code analyzer, that can be used to analyze the code being developed. So the prerequisite for this is the application source code should be available. During the development stage, module by module they may develop, so the testing can also be done as per the modules. And finally the integrated testing. Benefits is detecting insecure programming, outdated libraries, etc. at the initial stage itself. That is the biggest advantage. So instead of finding this error at the delivery stage, it is going to be costing, then that has to be fixed. It is going to take time. So at each phase the review happens and the errors are fixed then and there. Static binary code analysis and manual review. Analyzing compiled application to identify the vulnerabilities. That is, we saw this earlier. That is, there are static code analyzers. These tools will be able to identify the vulnerabilities. In general, this is similar to source code analysis, but it's not as precise, and fixed recommendations typically cannot be provided. Then we make use of the tools, testing tools, so supporting software built in-house, commercial off the shelf also. Now finally the coding is completed. Now executables are available. Now either a manual or automated test can be completed, can be performed. Simulates the live attack and identifies the vulnerabilities, the penetration testing. Automatic vulnerability scanners are available. Test the application from components and configurations known to be insecure, good for known vulnerabilities. Another testing tool is fuzz testing tool. Send random data into the large chunk to try to crash the application. These are different types of testing. Fuzz testing. This will detect buffer overflow problems, detect crashes that might be critical. The fuzz testing. Ongoing testing to ensure configuration is still secure and assumptions are still valid. And then the testing of patches, testing of changes, avoiding introduction of new vulnerabilities. So what it means is that we cannot just blindly apply the patch and then leave it with respect to operating system. We are now talking about the operating system. It has to be, there should be ongoing testing to ensure that configuration still is secure and assumptions are still valid with respect to the operating system. And when we apply patches, so after applying the patches, the application should be tested whether it is working as expected as earlier. Also, there might be some changes. After each change, the testing should be performed to ensure that no new vulnerabilities are introduced. During the development stage, the different levels of testing happens. The first one is the unit testing, the second one is integration testing, the third one is the system testing. Unit testing is precisely testing a small piece of code. The integration is testing two different modules, how it works when you integrate it, integration testing. System testing is complete, the complete application. Security and the privacy performance is in intended operating environment is working properly to ensure that. Procedures, data and results to be documented in a manner permitting you to reach objective pass-fail decisions. After the testing is completed, after looking at the document, a pass-fail decision will be taken, whether this application meets the stated requirement, like that, a decision has to be made. If it doesn't meet, then it has failed, and again one more iteration of fixing and then developing happens. Test plans and test cases. The test plans can be created right from the requirement stage. There are 10 requirements, means you can create test cases, as much test cases one creates, then it is better. There is no limitation for creating number of test cases. So the create as early in the development phases as feasible, right from the design phase. The test plan includes schedules when the different types, like design review will happen, when the code review will happen, when the integration testing will happen, when the like that schedule. The plan contains the schedule. It contains the environment, under what environment this needs to be tested, this application, and the resources for testing, the tools and the testers, what methodologies are going to be employed, a number of test cases, documentation of the test cases, how to reporting criteria, and what metrics are going to be collected, number of bugs, all created are available in the test plan and the test cases. Yeah, metrics is another important, after finishing the testing, the metrics is very important. That gives meaningful information, like whether the testing was effective, whether they could find out the number of, how many number of errors, how many fixed and how many still pending, that kind of information. The coverage is important. The coverage as a measure of completeness. If all the statements are covered in testing, then 100% statement is covered. Statement in the sense the coders, the application will be having number of statements. For example, if it is a procedural language, there are different types of languages, as you know, first generation, second generation, third generation, like that. The earlier generations languages were procedural languages. Currently it is object-oriented. The coverage is important. The tester should ensure that 100% is covered. Otherwise you test only one part, and if you don't find bug, and we cannot claim that it is working as expected, because we have not fully tested. Statement coverage, each program statement executed once and then tested. The branches, then testing the decisions. Within the application, these are all the programming concepts, like statement, branching, and then conditions within the application, multi-conditions, and then loops are there, path, data flow. Everything is a programming feature. So the testing should cover all these programming features. Like if there are 100 statements, for example, we should cover all the 100. If there are 10 branching, all the 10 branching should be covered in the testing. What are the conditions checked? 10 times, the 10 different conditions. So all needs to be tested. So that is the coverage. This is the test coverage. Testing of software changes. There could be a change in requirement. The user might have given requirements at one point of time, and later on he might change it. So when you implement that change in the code, again it has to be tested. Similarly, when you find out an error, then we make a correction to that error. That time again it is tested. Modified design itself undergo change. So again, after the design change, it has to be tested. The testing demonstrate the change is implemented correctly. Changes has not adversely impacted the unchanged parts. That is important. Like unchanged parts should not get affected. Requires regression testing and a regression analysis. The maintenance. Testing software changes is part of maintenance, software maintenance. Corrective maintenance in the sense fixing the bugs. Software maintenance is testing of software changes, and even hardware maintenance. Regression analysis is to reduce the scope of regression testing You narrow down to only what may have affected by the change by doing a regression analysis. Regression testing is needed because you have to rerun the test cases to provide assurance that the change has not created problems elsewhere in the software product. That is what we saw earlier. Let us suppose a user has given one change to the requirement and the coders have implemented that change. We cannot just test only that change. We have to whole test has to be repeated again to ensure that the unchanged parts is working as expected, as usual. There is no bug got introduced there. System testing is intended, in the intended operating environment to ensure that security and privacy are met, security and privacy requirements are met. The performance is as per the expectations or as per the requirement, like how much is the response time and reliability. Operation of internal and external security features, whether it is working as expected. Effective recovery procedures like disaster recovery. Usability testing. Compatibility with other software products to ensure the compatibility with other software products. Sometimes there might be the data might go from this application to the another application, so the compatibility issues to be taken care. So that is covered. Behavior of each hardware configuration. When a hardware configuration happens, there is a chance that the application may fail. So that needs to be taken care by testing. Accuracy and completeness of the document. During the application development, different types of testing. Again, we are looking at now different types of testing. Negative testing, that is misuse case testing. Test how the software handles invalid input, error conditions, and unexpected behavior. Negative. Populating the required fields. How to handle the blank fields. For example, here. Let us suppose the user has to type the age. Let us suppose age of a person. Let us suppose data entry is happening, and this person, HR person, is creating a employee record. So he is typing the new employee that has joined the organization. He is typing the name, age, everything like that. So now in the place of age, by mistake, if the user types 150. So it should be able to capture, it should be able to find out. So that's kind of a testing. Populating the required fields properly. Correspondence between data and field type. Here, the date, non-numeric. In a date field, if you type some alphabetics, it should reject, it should find out. Allowed number of characters. So if the name is, for the name, if we have set the limit as 20 characters. So no, more than 20 should not be accepted. If it accepts, then that is the buffer overflow. Error will come. Allowed data bound limits greater than and less than. The bounds should be checked. These are all happening during the application development itself. Reasonable age, I was talking about over 150. It may not be possible. Web session testing is test opening web pages not logged in. Whether before logging in, whether we are able to access the internals inside the application. Positive test, we saw earlier negative testing. Positive testing determines that your application works as expected. This is a normal path, positive testing. Negative testing is the abnormal path. Negative testing ensures that your application can gracefully handle invalid. If you do whatever is not expected to the application, it should be able to withstand. It should not fail. Then comes the interface testing. Different modules will be developed by the application developer. So how it works when you combine all the modules. So that is the interface testing. Check that the different components of an application or a system being developed are in sync. data transfer between the components working properly, interaction between the applications and servers are whether okay, working properly, errors are properly handled, same in the interface testing also. If the user interrupts a transaction, whether it is handled correctly. For example, the one operation has got two transactions. Let us suppose a person is paying some $1,000 to other person. From the first person's account, $1,000 to be deducted, and it has to be credited to the second person's account. So now, if when the computer has data from the database, the data has one account $1,000 has been detected, but at this point of time, if we interrupt, then it should credit that thing back, that is roll back. So that needs to be tested. Communication with the server database is performed correctly. All supported browsers have been tested. This is again, some applications will only work with one particular browser. It may not work with another browser. Sometimes with this particular version. So all that needs to be tested with all different versions and different browsers. Similarly, internal interface can users use copy paste or there is a leakage issue. Is encrypted and unencrypted data handled properly. This is within the internal interface. If left in the middle of a task, does it cancel automatically, or what happens? Does loss of internet session cancel the task? These are all related to the applications that web-based applications. The testing of different components we saw that is an integration test. For example, software and hardware combination, or software itself, there could be different modules. The combination, whether it is working properly. That integration test finds